Good day, I'm Maile Madziba. Welcome again to our channel. Today we continue with the 2017 study guide. We're looking at example 2.8.1. It says the heat capacity of water is 4.187 kilojoules per kilogram degrees Celsius. It says what is the heat capacity in A, kilojoules per kilograms Kelvin, number B, kilojoules per kilogram degrees Fahrenheit, number C, it is BTU per pound degrees Fahrenheit. So answering the question from A, I just want to highlight something just to give information. Now that we are within the heat capacity, so we've added temperature now to our studies. I just want to highlight something about heat capacity. Let me just write A as we answer A. Let me just write, this is actually the equation of the specific heat capacity, where C is equals to the specific heat capacity and Q is equals to the heat energy and M is equals to the mass, and delta T is equals to change in temperature. Now I just also need to highlight that the specific heat, it's actually the units, the normal units, SI units, is your kilograms, kilojoules per kilograms degrees Celsius, or kilojoules per kilograms Kelvin, and your heat energy, it's actually kilojoules, and there can be a variable of these units depending on the system of units, but I just wanted to use this because I want to explain this equation. And the mass is in kilograms, and the temperature is in degrees Celsius or Kelvin. So now with that said, when you look at the equation, you realize that that is actually where this equation, these units come from: kilojoules and kilogram and change in temperature. That is actually where it comes from. Now when they say that a heat capacity of water is 4.187 kilojoules per kilogram degrees Celsius, what is the heat capacity in kilojoules per kilogram Kelvin? Now we realize that they actually, in A, they changed only the temperature, right? It's actually, I'm sorry, I hope, let me just put the K clearly here. So only the temperature they change in this units. So what we need to highlight, what we're going to do now is that we're going to convert degrees to Kelvin, but there's something I want to highlight here. Let me just say 4.187 kilojoules per kilograms degrees Celsius. So now remember, this is actually delta. The temperature here is a change in temperature. It's not a straightforward temperature. That's why we're going to actually say that, well, we're going to actually convert the change in temperature. We can actually say let me just say 1 degree Celsius all over 1 Kelvin, right? And that's with that we cancel the degree Celsius, and then we left with 4.187 kilojoules per kilogram Kelvin. I just need to write here in brackets that we need to understand the reason why we used a 1-to-1 ratio is because the change in temperature in degrees Celsius equals to the change in temperature in Kelvin. That's why we used 1. I know when it comes to converting degrees Celsius to your Kelvin, usually one need to use your 273 and the like, but here the issue is we're using the change in temperature. I hope that's clearer. So that is actually our A. So now the B, they say convert kilograms degrees kilojoules per kilograms degrees Celsius. So 1.187, 4.187 kilojoules per kilograms degrees Celsius. Now we multiply by 1 degree Celsius all over 1.8 degrees Fahrenheit. Now this gives us 2.33 kilojoules per kilogram degrees Fahrenheit. Now here I also need to write in brackets that the change in temperature in degrees Celsius is equals to 1.8 times the change in temperature in degrees Fahrenheit. So that's why we actually use the ratio of 1 to 1.8. So that it's actually a B. Now our C, they say they want it in BTU. Let me just adopt this because already we know that if we can look at this equation, they want also in degrees Fahrenheit, and we also have we've already they want it in BTU per pound per degrees Fahrenheit. But if we check, we've already converted our degrees Fahrenheit. So I can just say 2.33 kilojoules per kilograms degrees Fahrenheit. Now, with this said, remember that degrees Fahrenheit is already changed. So which means for me to arrive in this units, I only need to change BTU and pound. And now I can just say 1 kilogram is equals to, I can say 0.4536 kilograms all over 1 pound, right? Is equals to 1.056888 kilograms per pound degrees Fahrenheit. Now I've changed for me to, well, from this units to this, I've already changed the degrees Fahrenheit, which I didn't be. I then changed the pound. Now I'm only left with changing the kilojoules. Let me just highlight here, just for the sake of following, like I promised at the beginning of the sessions. So we know that 1 pound is equals to 0.4536 kilograms. Now with that said, for us to get, we only left with the kilojoules. So we're gonna be converting to BTU. So I can just say multiply by, for me to change the BTU, I can say 1 BTU all over 1.055 kilojoules. That gives me 1.0 BTU per pound degrees Fahrenheit. Now in bracket, I just need to highlight that 1 BTU equals to 1.055 kilojoules. So that is basically how to answer this equation, or rather this question in itself. We've actually answered it in both A, B, and C. So I hope it's clearer, and thank you also for your time. Hope to meet again in our next video.